software already, and right now you need to go to the option and the environment to change your unit. Because after you install, your unit is English, and right now we use that's a unit for you to use. And here, directly you can select, you can define your problem by which you want, in which folder, or you don't want to change, it's okay. But when, for you, for convenient, you can change your unit before and click OK. And remember, go to the option and set the current setting. Because if you don't save, you need to go to the environment to set the unit each time you open the software. Okay, and right now, I'm showing you to create a subfolder. And I create a new name is for code upsetting. Okay, in this folder you cannot use, if you want to name it, you cannot use the space like this. It's not acceptable, okay? And you need to attach. And this folder cannot use Chinese. Okay, after this, after you create, you just click here and go to the preprocessor and click the Deform-3D preprocessor. Okay, in this screen, this preprocessor, right now you need to do one thing to change. Go to the simulation control to change your simulation title, because it is more easy for you to organize or recognize your simulation is for what, simulation processing, and title is what things. And operation name, because this is for use to multi-operation process. Because here operation name is more easy for you to understand this is what operation process. And click OK. Okay, right now you need to go to you need to add the punch and the line, and you just click the insert object. After one click, the system will automatically show this is a top die, and click again, they will show a bottom die. If you click too much object like this, maybe you just need to click the delete object is okay. Okay, right now we need to select in here, always from up to down, and your setting always from up to down, to left to right. Okay, in workpiece you need to, for me, I will change the name. I will call this is Billet, and your code upsetting process is your temperature is 20 degrees, and right now you need to assign this Billet their material. Okay, in this filter, if you have too much standard, you need to select. You cannot find your standard, you can just use this filter to select which one you want. And for me, I use AISI, it's a USA standard. And I select here, this is a low carbon steel. Okay, from here, I will check again, is this correct or not? You just need to click here. This is material. And check again, material list, is this AISI low carbon steel? And you need to check, is this a flow fed import or not? Okay, and go to the geometry. in geometry, you need to create a geometry, and you have two ways to create. One is import by geometry. It means before import you can use CAD to draw your geometry, and you need to save the STL file. And the other way is go to the primitive. In here, you have three types you can choose. One is box and cylinder and hollow cylinder. And in this case, we use cylinder, and their diameter is 10 millimeters, and the height is 30 millimeters. No need to corner radius. And after you click create, you will see in that window there will automatically create about this one. If in here you need to do one thing to check your geometry. This is very important when you use the import geometry from your file, this button. Because sometimes your CAD file has some problem, have some defect about your surface. Maybe a hole, maybe your contour is not closed, your contour is open. So you need to go to check geometry, you need to click. And remember, a number of the surface in 3D simulation, in each object, need to only one. If you this number of surface show about maybe 2 or 5 or 10, it means your CAD file has some problem. You need to go back to your CAD software to check your geometry. Okay, and here, go to the mesh. In here, in this case, we use automatic mesh, it's okay. Or you don't want to use automatic mesh, you can use. Here, this is, we also call this window, this tab is by manual mesh. Because this is setting more details from your mesh system. Here, you can general by relative or absolute. And the size ratio, 3 or 4 in the deform suggests you 3 or 4 size ratio is okay, but not too big. Not bigger than 4. Okay, go to the, and you just click the surface mesh. Okay, surface mesh just show you this is they create about your mesh, element mesh from your surface. They show you from surface. And if you want to simulate, you need to click the solid mesh. Okay, here. In here is in the first tab, in the final tab is we call remeshing criteria. It means your element. For example, if I use interference dip by x by absolute, it means if each element, some element, their interference between two elements, if their interference dip larger than 0.7 millimeter, they will trigger the remesh criteria. And relative means if I select 0.3, I type 0.3, it means between these two elements, their interference dip, if approach, their ratio approach 0.3, they will trigger the remesh criteria. And here we have remeshing methods. It means if a trigger remesh criteria, what kind of remeshing methods you need to use? Here is global remeshing. It means from your list limit will global remeshing, or you can choose local remeshing. It means For example, here, if I select absolute 0.5, and the remeshing methods, if I select local remeshing, in here means these two elements approach the 0.5 interference speed approach 0.5, they will trigger, and they use local remeshing to remesh these elements. And here we have size control. In size control, usually we use average of the neighbors. Why? Because you cannot always calculate by yourself for what scale factor you need to use. So we use the average of neighbors. And this option can save you more times if this element is a good shape. If you click this option, it means there will skip remeshing if this element's shape is good. Okay, after meshing, you need to go to the tools here, tools tab. You need to click check mesh. And remember, if later we have used I will tell everyone we have two types to control your movement, your simulation solution states. We have time displacement increment, or the other one is time increment. If we use time displacement increment, please remember this value. This is very important. Minima edge length. It means okay. Right now we remember about this is 0.26. Click OK. Okay, we go to the simulation control and step. In here we have definition is by displacement step or time increment. You have two option you can choose. Usually we will use time displacement because this is more easy for you to control, because you have die and you have punch, you can control punch their movement, how much displacement you need to move. And in time increment, usually we use for heating. For example, you go to you put this workpiece, you need to raise up the temperature from maybe 25 degrees to 100 degrees. Because in this case, if you want to improve, you want to raise your workpiece temperature, you cannot use time increment, time displacement increment, because you don't have die. You just to raise your temperature up, so we use time increment to control. And in this case, it's upsetting, so we have a punch, so we can use time displacement increment to use. And here, you need to select 1/3. The maximum time displacement movement is 1/3 about this minima edge length. So your time movement by time displacement, their maximum movement is 0.088. You cannot larger than this value. But you can smaller for it, because for you maybe 0.088 is very not so easy for you to calculate. So maybe you can click type 0.05. Okay, after meshing, you don't need to select about movement, because die is your primary movement die. So in the Billet, you don't need to define any movement. And here, this is we call boundary condition. In boundary condition means sometimes we will use, for example, this is a half of the geometry. If this is symmetric geometry, we can use 1 you can use half or quarter for you to simulate about this problem because this is more faster and more save time. But in here we use the whole geometry, so we don't need to define any symmetrical plane or velocity or pressure, no need. Okay, in properties, you need to notice about the target value. Because in simulate, if they trigger the Remeshing criteria, if you don't target your value finally will lose value while losing. So here is they're telling you the value of the mesh is this value, and your geometry, the value is this. And the difference between this value is 0.25%. If you acceptable, you just click yes. If you not, you click no and go to the mesh to remesh again. Delete mesh and generate mesh again. Okay, right now it's finished about Billet, about the setting, and you need to go to the top die and geometry. We change the object name. So it's about notch. Also click the geometry button. Create system. And the punch and the die, their dimensions is diameter is 30 millimeters and the height is 10 millimeters. Just create. Okay, make sure this surface is one. Go to the movement and the speed. This translation type is about the speed. In here, you have a lot of type you can choose, like hammer, mechanical press, or force, or screw press. And then in this case, we use speed and their movement. Then punch speed is about 10 millimeters per second. And their dimensions is the same as the punch. Okay. After create, about this, you need to move their positioning. You need to define their positioning, and just click object positioning. For you to more easy to understand some objects. Okay, here you can see the top is the punch, and the middle here is the billet, and the final here is the die. You click again. In here, usually we use, we have 5 methods we use, draw, offset, inference, or rotational. And usually we use two methods. One is offset, the other is the interference. And right now you need to select which object you want to position. For example, I want to move Billet to contact about the die, and their contact band is about the bottom. So here you choose which one you want to move. If I want to move Billet, so you just select Billet, and their approach direction means you want to contact by which direction. For here, I want to The billet needs to go down, can touch, contact the die. So I use the negative Z axis. And then you are referred by what object? Means you want to contact by which object? You select die because I want to move down the billet. And you click apply. They will contact. And right now, we need to move the punch. Go down to contact the billet. So here is also move punch. Select punch, and also they will go down, so it's negative Z. And you choose negative Z. And you want to, the refer is by billet because punch will touch billet, not touch the die. And you click apply. And after that, remember, after you click apply, remember to click OK. If you don't click OK, you just close. They will return the initial position. And here is a message window. They are telling you if you have some boundary condition, after you positioning, the boundary condition may be changed or may be different. So you need to go to the boundary condition to need to check again. But in this case, in this offsetting case, billet, we don't define any boundary condition. Okay, after that, you need to define their friction. In here, if you click interference about this interference object, their relations, the system will tell you, do you want to help you to deform their relationship for you? You can choose yes or you can choose no. If you choose yes, the system will automatically help you to create their relationship between each other. So right now we can see have two relations. One is punch to billet. The other one is die to billet. And punch to billet, we go to the edit button. We click edit button. In here, in deformation tab, we can select define your friction, and your type is they have three types you can choose. One is the constant shear. The other one is the crucible. And here is from hybrid. Hybrid means they use constant shear and crucible. In this case, we use constant shear. And click this button, they will help you. They will tell you some. Usually we use their friction. For example, if your die is carbide die, maybe they can tell you this is friction is very low. So you can click 0.08. But in this case, in our simulation case, is 0.1. So you just type 0.1 here. It's okay. And close. And here, if your friction coefficient is the same, you can click apply to other relations. If not, you also need to click again and just type your value. Here, you need to highlight about this after you type the value and click apply to other relations. The system will help you to setting about the other relations. And after setting about that, you need to click forward and click generate all. And later, after I click generate all, you will see here have a contact node. Here is about the contact. click OK. And from here, this one is about 30 millimeters, and we want to die will move. Their displacement is about 25 millimeters. So here, go to the simulation controls. Step. Here is in starting step number is always -1. Here, number of the simulation steps need to times about if you want to move 25 millimeters. How to calculate is how to calculate your total steps. You need to your total steps equal your displacement divided by die displacement. It means if I want to move the punch want to move 25 millimeters, and and I set about the die displacement is 0.05 per step. So here is calculated by total step. How many steps you need to use? Here is 500 steps. And this one is after your simulation, you go to the post process. You can see their animation, and your animation is you want to see how many steps. Step increment. It means if you type 1, it means they will go to -1 and the step 1, step 2, step 3 to step 500. If you type step increment to save, but if you type 10, it means initial is step -1, and next animation is step 10, and the other one is step 20. Okay, here in the third option we have we call stop control. Because right now, because sometimes maybe you miscalculate. Maybe you calculate by 1,000. So maybe you can use the die distance. Here means you choose about which distance between the two objects. For me, I select punch and die. And their method is z distance because they will go, their movement is by a line from the z direction. So here you just need to select. This one. And this one. You can see. Here you can use the method is z distance, and you need to type maybe 5 millimeters. It means if these two objects, their distance approach 5 millimeters, the system, the simulation will stop. You click OK. And if you select wrong, you just need to click here. This hammer is initialized. Okay, after setting about the simulation control, it is right now you need to generate the database for your simulation. You click check. This one can the database can be generated, and this warning is just tell you because your target value and for this object one is Billet. Their mesh value and their geometry value is different, so they give you a more warning. If you assemble, you just need to click generate. If you not assemble, you need to go to the mesh and delete mesh and maybe larger elements, number of elements. Okay, after generate, you need to click save. Why you need to click save? It means click save. They will save about we call key file, and you generate database. They will show only generate DB file. But if you simulate, because for example, if your case is similar and just different parameters, process parameter, for example, your friction is different, or your side movement is different, and the other one, geometry is the same, and then your material is the same. You don't need to go to recreate about the problem. You just can just click the key file and go to the preprocessor. And here they have the system detect you have EB file. They will ask you, you want to open it? But if the EB file is simulating, you cannot open it, so we click no. And here you can see, if I save the key file, you can very easy for you to modify some parameter like your temperature you want to raise up, or your punch movement and the speed you want to raise up or decrease is also okay. And after that, you just need to click again and create a new. They will save again. Okay, and you want to simulate. If you want to, you check again, it's okay. Your this DB file is okay. You want to simulation. Go to the simulator and click wrong or wrong option. Wrong option means you can use multi-processor. Here, multiple processor to help you to simulate about this problem, because this one is more